Hello, my name is Dr. James Kirkham. I work at the International Cryosphere Climate Initiative, where I'm the Chief Scientific Advisor of a high-level group of countries called Ambition on Melting Ice. I'm going to talk to you today about the state of the Earth's cryosphere, the regions of frozen ice and snow, and why we need to have radical policy action today to prevent catastrophic changes and downstream impacts in the future. So, 2023 has been a devastating year for the cryosphere. Thresholds have been crossed. The latest science shows that the impacts are going to come sooner and be higher than projected, and we're already seeing the devastating effects of cryosphere loss today. This is because the cryosphere is warming faster than anywhere else in the world. The Arctic is warming at about 4 times the global average, whereas Antarctica and the Hindu Kush Himalaya are warming at about twice the global rate. This means that whilst the Earth has warmed 1.2 degrees on average, we're heating our cryosphere with 2 or 3 degrees more at least than it was in the 1980s. Now, this rapid warming should alarm the world, and this is because the cryosphere has some of the earliest tipping points of the entire Earth system. The cryosphere has 5 pillars. We have mountain glaciers, polar oceans, frozen ground, permafrost, sea ice, and ice sheets. And in this figure you can see a map of the various tipping points that the Earth system has. And if you look closely, you'll see that 13 out of 16 of these tipping points relate to the cryosphere. And most worryingly of all, many of these will be triggered at less than just 2 degrees of warming. The outlook for mountain glaciers and snow in 2023 is shocking. It's taken less than 100 years to go from this image to this. In the Alps, bedrock is becoming visible at many glaciers because they are so thin that imminent loss is about to occur. Glacier funerals are becoming increasingly common as scientists and communities say farewell to these incredibly important economic and cultural resources that are literally melting away before their eyes. The big picture is this. We are now committed to extensive mountain ice losses. These graphs show the different pathways that our mountain glaciers will take under different temperature warming scenarios. In blue, we have 1.5 degrees. In orange, 2. And red is our current emissions pathway. What you can see is that even at 2 degrees, Europe will lose 80% of its glaciers by the end of this century, and the Hindu Kush Himalaya will lose about half of its glacier volume. But if we continue on our current emissions pathway, which will blow past 2 degrees very quickly, we're set to make glaciers around the world extinct by the year 2300. Now, we're already committed to some mountain ice losses, but it's not too late to make a big difference. The outcome towards the end of this century is still to be decided. In these animations, you see the difference between a current emissions world and very low emissions. And what you can see is that by acting now, within still realisable pathways, we can save a good proportion of ice, which will provide water resources to critical downstream communities. As well as this, it will take longer to lose the ice, which will give communities more time to adapt. Action today makes a big difference. 1.5 is our best chance to save mountain glaciers and snow. Moving on to another pillar of the cryosphere, this is polar oceans, where the carbon dioxide we are emitting is being absorbed by the water, and this is making it more acidic. And the issue with this is that it's corroding the very organisms that provide the foundations of the food chain in the global oceans. You can see the shell doesn't look normal, and this is because it's literally being eaten away by the acidic waters that we're generating because of our CO2 emissions. This damage, if we continue, is essentially permanent because the oceans will take up to 50,000 years to recover. But we've got a choice still. In this figure, you can see what we're heading towards under current emissions. Huge areas of our global oceans which will be terribly affected by this acidification. But if we act now and radically reduce our emissions, we can limit the damage to only a small area of our polar oceans. Permafrost thaw is vast across the world and has huge potential to disrupt infrastructure and also contribute to carbon emissions. In this map you can see the orange areas are areas that will be thawed by 2050, and this will cause enormous impacts on settlements, railways and industrial areas. But as well as this, as the permafrost thaws, it releases carbon dioxide and methane, which then further contribute to global warming. Today, emissions from permafrost thaw equal the same amount as Japan emits every year. But if we continue to push our world into ever warmer temperatures, at 3 or 4 degrees, this permafrost thaw will be releasing the equivalent emissions of the US or China today. We have to reduce our emissions now to stop the warming temperatures. For Arctic sea ice, even 1.5 degrees is too late, and that's because the very latest science shows that there will be ice-free summers in the Arctic, even at 1.5 degrees. This will have massive implications and global feedbacks that will further warm the Earth and result in more ice melting and more impacts. But again, we have the same story. Acting now prevents the worst of the damage. At 1.5 degrees, the Arctic will be free in the summer occasionally, but at 2 degrees this will occur every single summer. Acting now, again, makes a big difference. 1.5 has to be the red line for the cryosphere and Arctic sea ice. For ice sheets, we've watched in recent decades as these giants of the Earth system have woken up and are contributing increasingly to sea level rise. These maps show in the last 20 years how the ice is being lost. Red areas are areas of these ice sheets where ice is being lost and is not being replenished. The worst 7 years of ice losses have all occurred in the last decade, and currently losses in Greenland that we're observing as scientists today are tracking above even the worst case projections of the IPCC. The result of all this ice melt from glaciers, thermal expansion of the ocean, and of course ice sheets is sea level rise and coastal flooding. And together, these sources have made sea level rise by 23 centimetres since 1880. Now, this is already a lot, and it's causing huge damages. And the science about this is getting better at attributing the role of climate change and the role of fossil fuel emissions in driving these impacts. And so a recent study showed that these 23 centimetres of sea level rise caused by fossil fuel burning led to an extra $8 billion of damage during Hurricane Sandy. This $8 billion would not have occurred had we not caused sea level to rise by just 23 centimetres. Now, unfortunately, 23 centimetres will appear very small compared to what is coming in the future. By the end of the century, sea level will rise by 0.5 metre to 1 metre. This is now locked in. What is most concerning is that this dotted line, the low likelihood, high impact storyline first proposed by the IPCC in AR6, is now looking increasingly likely based off the recent science. In this pathway, we could be feasibly seeing up to 10 metres of sea level rise by the year 2300, unless we act now. Now, I know what you're thinking, this could be just a projection, but no, we have evidence for this. So last time the Earth was 1.5 degrees warmer, we know that sea level was 10 metres higher. This is a notch in Italy carved by past sea level, and what you can see is this notch is 10 metres higher than it is today. So the Earth's ice sheets send us a very clear message from the past. If we exceed 1.5 degrees, the Earth's ice sheets and glaciers will melt to a devastating degree, and this will commit us to extremely long-term extremely high magnitude sea level rise that will exceed the feasibility of adaptation. The decisions we make in the next few years, we have about 1 decade to decide this, will commit us to sea level rise for centuries to come. There really isn't much time left to act. Now, to give you an idea about what this sea level rise would look like, here are some cities that will be affected and have to deal with the sea level rise commitment. This is Shanghai in China, under 1 metre of sea level rise that is now committed at some point in the future. This is what it looks like with 3 metres of sea level rise, which could be achieved with our current emissions in the early 2100s. The impacts would be even worse, potentially 10 metres by 2300 with current emissions. The same goes for Mumbai with 1 metre, which is now committed. 3 metres and 10 metres. Bangladesh in particular will be hard hit by this sea level rise, with up to 18 million people displaced in the next 30 years. The impacts of this would be devastating with just 1 metre of sea level rise, but unimaginable with 3 metres, let alone 10 metres. Karachi in Pakistan will also be inundated very soon under very small levels of sea level rise. This is 1 metre, 3 metres and 10 metres. So what can we do about this to mobilise action in the face of such extensive cryosphere losses and large downstream impacts? One avenue I'd like to raise is the Ambition on Melting Ice high-level group on sea level rise and mountain resources, water resources. This was formed at COP27 last year. The idea of the Ambition on Melting Ice, or ARMI declaration, is to ensure that the impacts of cryosphere losses are understood by world leaders globally. We're currently 20 countries, but we are growing. And we hope that many more countries will come together and take on this message, this very, very key message that we need to reduce our emissions now, keep warming below 1.5 degrees to ensure that the impacts of cryosphere loss will not be devastating, as they could be if we blow past 2 degrees. So to conclude, we cannot negotiate with the melting point of ice. 1.5 degrees has to be a red line for the cryosphere. The science of this is evolving much faster than can be captured in the current IPCC reporting cycle timelines. And the very latest science tells us that the cryosphere has lower thresholds, will respond faster to warming with irreversible impacts. And all of this means that our key message is that 2 degrees must be taken off the negotiating table entirely at COP28. 2 degrees is not an option, 1.5 has to be the red line for the cryosphere. Thank you.